Well, thank you very much for joining us this afternoon. So we're going to essentially be talking about augmented and virtual reality, but specifically, how can they be used in conjunction with one another? How do they relate to one another? And then how does that support the multi-domain operational environment? And in order to have this discussion, I have an esteemed panel with me. The first one up, we have Mike Amori from Virtualitics. And then we have Lieutenant Colonel Ryan Riley from the United States Air Force. And we have Dan Robinson from Red 6. And Suzanne Borders from BadVR. Let's have a seat. All right, so I'll kick this off and just give a little bit of background in terms of who I am. It was announced I am the president of the AR/VR Association. It's a global association around the world. I also host the podcast for the association, so I end up getting to speak to a lot of really, really interesting companies who are mostly in industry that are doing some incredible things with immersive technology in general, referring to augmented and virtual reality, as well as artificial intelligence and beyond. And then I own a company called Brightline Interactive, and my company designs and codes immersive technology for DoD and IC. And as a part of that effort, we get to see some incredible technologies as well. But my friends up here are also doing some amazing things, and I wanted to if we could, just start down the line. We'll start with you, Mike. If you could just kind of give us an understanding of who you are and kind of what you're doing with the company, and specifically how it fits into the VR and AR space. And then we'll do the same thing across down the line here.
Sure. So Virtualitics is a spin-off from research done at the California Institute of Technology and the NASA Jet Propulsion Laboratory over the last 10 years. And it basically is a software that allows people to visualize and present insights in data very quickly and more effectively than traditional tools. And the way we do it is by combining AI with 3D visualization. So the AI piece helps you find the insights in your data, and the 3D visualization allows you to see multidimensional insights better. The VR piece comes in allowing people to actually present those insights in a much better way than just sharing a screen, in telling a story about the data, and being inside the data with others.
Great, thank you very much, Mike. Lieutenant Colonel?
Yeah, I'm the commander of Detachment 24, one of Air Education and Training Command's innovation units. We've been tasked to explore the space as far as for revitalizing pilot training, as well as also how do we train multi-domain airmen that are going to thrive in peer-level conflict. It's really cool when we talk about AR and VR as far as how to take complex information and synthesize it, both in the learning environment and also in the application. And that goes, what you've heard already in our air operations centers, which is where we're synthesizing a lot of complex data. So we're trying to pull elements of the virtual and the augmented realities so that we can, train people faster and better, but also get them to synthesize complex data so they can make the informed decisions that we need in the current battle space.
Great. Dan?
Yep. Hey guys. So I'm coming at this from with two hats. As a former operator, I was an RAF fighter pilot, Brit Weapons School graduate, and then lucky enough to be the first guy to fly Raptors for the US Air Force back in 2006, 2009. And I didn't know it then, but that was the genesis of Red 6 Aerospace, and I became the founder and CEO of Red 6 in 2018. The reason I founded Red 6 was because I was really passionate about a problem that we were struggling with, and you will all be intimately familiar with, even back in 2006, and that is training. How do we fundamentally train? And we were struggling to put assets up into the air. We understand there are huge opportunity costs to putting guys and girls up to provide red air. It's really expensive, and critically, how do we train against near-peer adversaries? And that was something that we were just failing. It's only gotten worse since then. It would be fair to say that we're in a crisis right now. We're 2,000 pilots short on the front line, and that is becoming an increasingly difficult problem to solve. So I formed Red 6 in 2018 when we figured out fundamentally a unique solution to augmented reality. Augmented reality right now is fundamentally an indoor solution only. the best in class. As soon as you step outdoors, it doesn't work. As soon as you go in dynamic environments and move around, it doesn't work. What we've done at Red 6 is figure out how to make augmented reality work outdoors and in dynamic environments. And my vision is we put synthetic aeroplanes into the sky on which we can train against. My vision for the future is that we no longer put a physical red air asset in the air. We don't need to. Using synthetic training, live virtual constructive, and a combination of the tech that we've developed, I don't think we should be putting physical assets into the air anymore.
Great. Susie?
Awesome. Hi, my name's Suzanne Borders. I'm the CEO and co-founder of BadVR. We're an immersive data analytics platform. And what does that mean? It means that we take really large, complex data sets and put them into virtual and augmented reality, with the goal being to make it easier for everyone to be able to access their data and find insights, better insights, faster. We're very passionate about democratizing access to data and making everybody, essentially, a very powerful data scientist and giving everyone a shared context, contextual understanding, and awareness of multiple different types of complex data sets.
That's perfect. Awesome.
Thank you.
Great. Okay, so generally speaking, what's happening here is we have a bunch of companies up here in industry, representing industry, who are working inside these technologies. Oftentimes what happens, though, with these technologies is they end up getting siloed into a particular track at a conference or even inside a department. And so you have people working on augmented reality, and then people working on virtual reality, and then people working on artificial intelligence. And really, strategically, it becomes difficult to try to figure out how you're supposed to integrate them. Generally speaking, I refer to it as the immersive ecosystem. This is a product, something that my company is working on building an engine. And essentially what we describe as the immersive ecosystem is we're collecting information, we're collecting data from edge computing, from sensors that have been embedded into traditionally non-electronic equipment in the field. We're taking that data in, we're storing it either locally or cloud-based, and then we need to interpret that data. We need to make sure that the data that we're collecting is relevant for the environment in which we would like to train. And so we use a recommendation engine, which is a subset of AI, to tell us what type of information should be displayed inside virtual reality. Because then once you get to VR and AR, really where you've arrived is the visual engine for big data. The best way to visually contextualize the information, which we'll talk about. And then we want to measure that data. So once somebody's inside simulation, you want to know how they're performing. And we want to let that performance actually change and adapt the way that we deliver the scene on an ongoing basis. We call that the immersive ecosystem, and it's important to think about all of these different technologies. They're certainly subset technologies, but they have a relationship and they're interconnected. And we're going to sort of demonstrate that based off of the expertise that's here on the panel. We're going to start with you, Dan, just talking about, maybe if you could, I mean, you said it in the opening, but if you could tell the audience, just give everyone an understanding of what the product is that you're working on, where you're showing actually red aircraft through the existing visor of the pilot's helmet.
Sure. So I think it's worth framing the overall landscape of AR and VR. My personal take is that VR will ultimately be a subset of AR. The future is an AR future. Of that I have no doubt. But the problem is, right now, AR, as I said in the opening, is an indoor solution only. And as soon as you step outside, it doesn't work. So it has limited use cases. My personal take is that AR is an interesting technology. It's kind of a solution in search of a problem. But for a ubiquitous AR solution to be out there and mainstream, it has to be mobile in nature, and it has to be able to work outdoors. If you can do that, now you have real use cases for AR. So what we did at Red 6 Aerospace, we started off actually with 2 race cars. And we put 2 guys in VR in race cars on separate tracks, one in the UK, one in the US. Both guys in real race cars on real race tracks went into a VR world, they met each other, and they raced. We've taken that technology and evolved it into AR now. So what we've developed is, and actually in conjunction with AFWERX, which is how we got our start, is a complement to the live virtual and constructive ecosystem. Live virtual constructive or synthetic training is undoubtedly the way of the future. It has to be. However, live virtual constructive is only a 50% solution. Why is that? Because it's a beyond visual range solution only. So as soon as you get inside of 10 nautical miles and you start to go from that, looking at the radar scope to heads out, where is that guy? I'm going to put my gum shield in and go for a fight. The whole training system collapses. Why is that? Because we can't visually display them. Why is that? Because augmented reality doesn't work outdoors. It doesn't work in dynamic environments. Well, it does now. So at Red 6, we've created a patented visor technology, which we're developing. Certainly over the next 18 months, we'll have a 120-degree field of view outside, daylight-capable, low-latency display. My vision is that we can look through that display, which incorporates into a helmet, look out and see virtual airplanes, which we can go and fly and fight against. And the beauty of that is if we have the intel on the platforms and we can code, that we can go train against anything we need to, be it J20, PAC-FA, and all of a sudden now the training gets relevant. Second to that is, we are critically short on pilots on the front line. So we have to be smart about how we keep our pilots and how we train our pilots. And the stuff that you were doing with VR and PTN is a great start, but I think we have to go further than that. So every time we're putting a pilot up to train and be red air, he's not doing what he should be doing, which is blue air. And that's exactly the value of the product we've developed at Red 6. We can go up, we can use all of our pilots, all of our assets to fly blue air, therefore mitigating, bringing costs down, and not having to provide red air.
And you just said, bringing costs down. I think that's an obvious sort of result of training in the way that you're talking about. What is the actual? You're a pilot yourself. What is the human impact on training in this way versus training with physical aircraft?
I think there's twofold. There's a bunch of pilots in the audience, and even you guys know the days that you work. You know the fatigue. You know the loads on the strains on the family. So the first thing is the physical demands on time and effort for the pilots are reduced drastically. Secondly, we're spending billions of dollars a year providing red air assets. We should not be doing that. We need to be smarter with tech to mitigate those problems. And the obvious question I get asked is, well, why don't we just do this in simulators? Well, we know anyone that's stepped into a fighter airplane, be it an F-22 or something else, and you're pulling 9 Gs, the fundamental difference or the cognitive load on the operator is absolutely different to being in simulators. So if we accept that we have to train in real life and we have to go up and fly airplanes, then how do we do it smartly? We need to be preserving our assets. We need to be using them for blue air sorties only. And we need to be using technology, AR, LVC, to provide red air assets. And if we can do that, we fundamentally change how we train.
That's perfect. And so what you're talking about, and just to give full context here, is augmented reality as displayed by objects that have a physical, an original physical context, right? We're talking about an aircraft that does actually exist physically, but in midair, it's not being displayed physically. It's being displayed as augmented content, right? And so that is one subset of augmented reality, is displaying content that actually does in fact have an original physical context. But there's a whole other subset of augmented reality, and I think it is slightly less accessible by nature, and that's augmented reality as displayed, which is displaying content that does not have an original visualized context. It's abstract information. So we're talking about signals and communication and data and being able to see this as lots of people call it, ones and zeros, as an overlay in the physical world at the same time as the content that you're seeing in products like what Dan is making. And so just to talk a little bit about that, maybe Susie, could you just tell us, why is it important to be able to visualize abstract data?
Well, data is power. Data is knowledge. If you can't see it, it makes it exceptionally hard to understand it. And if anybody has worked with any sort of abstract idea, let alone abstract data, it's very difficult to both communicate your insights and also to find those insights if you can't have some level of visual representation. There's a reason why there's a saying, a picture's worth 1,000 words, a picture's worth 1,000 ones and zeros. That's why it's important to look at abstract data and to also be able to allow everyone the ability to look at this abstract data set. And speaking to some of the uses of augmented reality when visualizing data, my company, BadVR, we have a product, it's called C-Signal. And the name is very well descriptive of what the product actually does. It allows you to put on a headset and actually see the signal data within your room, contextual to your environment. So imagine being able to see for the very first time your Wi-Fi, Bluetooth, and cellular networks. You're no longer having to guess where the dead zones are. You're no longer having to walk around the room and sort of trying to understand what the actual signal looks like. And when it comes to RF modeling, When people do this, right now they're using flat screens, but the reality of it is it is multidimensional. When it's gathered, it's multidimensional. When it's displayed, it should be also multidimensional. So that's an example of like visualizing data, abstract data, using augmented reality, contextual to an environment. But it is also very much an artistic challenge. So like, what does a Wi-Fi network look like? What does that data look like? How do you present that data? It's easy to say, okay, well, I know how to present an aircraft because we all know what an aircraft looks like. But what does Wi-Fi data look like? What does Bluetooth data look like? And that's definitely been a challenge that my team has been working on, and I think it is an important challenge to discuss when we are working with visualizing data using augmented and virtual reality. And keep in mind that it's not just an engineering challenge, it's not just a technical challenge, it is also a creative challenge of coming up with what this data is going to look like moving forward into the future, what these future interfaces will look like. They will be immersive, but is it going to be Minority Report? Is it going to be Avatar? Which of these futures is it going to look like? So.
And Michael, you have a similar experience. I mean, you're working on similar style projects, visualizing abstract and at times very complex data sets. How have you seen virtual and augmented reality being sort of an assistant to being able to contextualize such abstract data to decision makers?
Sure. We're fortunate enough to have a contract with the Navy and 2 contracts with the Air Force. In all these cases, we see these incredible people, the operators on the field, who have domain knowledge. They know exactly what they're looking for in the data. They understand the context of the data. And they have access to all of this data. But they're not data scientists, and they need to find a way to really visualize the key insights that they are looking for in the data. And the VR helps unlock those insights for them. So it helps people really see the multidimensional context of the data. And then it also helps people, once they found the insights, present them to others. So in our company, we have a shared virtual office that people can connect in who might be very geographically dispersed from each other. And imagine in front of you, you have the data floating in front of you. And there is a presenter who can interact with the data, tell a story. There are infinite screens that you can paste your data in. You can really tell a story, and you can collaborate with others and interact with the data together. So those are the kind of things that we're doing for the Navy and the Air Force. And one of the contracts is actually about building the command and control center of the future, where you are streaming in data, possibly live data, lots of it, running machine learning algorithms that point you to the right direction, and then sharing that live with a bunch of people. Those are the kind of things we're trying to do. But the key is to unlock the insights for non-data scientists.
Right. And Susie, you and I were talking about this earlier, but we collectively, and I'm sure we agree, we think it's oftentimes almost comical when we think about trying to represent abstract information inside virtual reality. Now you have a medium of communication that allows for what's called implied body ownership or simulated body ownership, where you believe that you exist inside that scenario. And because that's true, it actually changes the way that you can take in information. And so what is somewhat comical to us at times is when people tend to understand a new thing through the lens of an old thing. And so you can take your awareness of something that's new and you just sort of supplant the old way of communicating into that new realm. And so what you end up with is bar graphs and charts inside virtual reality, which is somewhat comical because the idea of a bar graph, the idea of a chart, it was intended for the limitation of two-dimensional communication. Whereas virtual reality, we no longer have those limitations. And so what are some of the ways, I mean, you talked about it earlier, Susie, just in terms of the design standards, so much of what we're communicating is very complex abstract data, but it boils down to how are we going to visualize this for people using these technologies?
Yeah, I mean, I think when you look at the limitless potential of immersive technology, if you try to take sort of the old way of doing things like you were discussing, charts and graphs, and putting them into an immersive space, you know, that's sort of like level 1. But if you want to go a little deeper than that, and you want to fully utilize the potential of immersive technology, you have to really rethink what data looks like. as I mentioned earlier, if not bar charts, line graphs, and scatter plots, if not dashboards, what could it be? And especially in a multidimensional space across multiple different types of data sets, this has the potential to look like something we've never seen before. So again, it is a creative challenge. It is an artist challenge. What does this data look like? And on our team, what we've done is instead of using any sort of charts or graphs, we went and threw that away. We were like, that's the old standard. They exist because of the limitations of 2D screens, okay? We're going to build the new immersive standards for visualizing data. And so of course, they have to be reusable. So they are not, one-off data environments, but what we have are 4 unique immersive environments, the new immersive standards for visualizing data. And these environments maintain their same structure regardless of the data that you put into them. They are fully immersively interactive. They can show live data streams, but they are suited to particular types of data sets in the same way that some charts are suited to some specific type of data. Each one of these immersive environments is suited to a particular type of data. So that's what we've done. And we've also, of course, experimented with augmented reality and the ways to display data using that. We found that VR is good for some types of data sets, very, very large scale abstract data sets. Augmented reality is really good for contextual data sets that exist within a specific room, overlays, data overlays. So we have standards, new immersive standards for both of these types of environments, and we are continuing to push forward in developing these new sort of best practices for working with data in immersive spaces. I would love to describe a little bit more about the structure of these environments, but I think I could go on a tangent with that forever. But feel free to come by BadVR's booth and we can show you some of the new ways beyond charts and graphs that we're looking at and working with this data.
Yeah, and so what we have here is we have both subsets, right? You have physically represented augmented reality assets, virtual assets that do actually have an original visual context, right? An enemy aircraft. And then you have abstract data that does not have an originally intended visualized context, but we're giving it visual context using augmented reality. And so how does this, to you, Lieutenant Colonel, how does this, you're talking about in your opening, talking about making complex decisions, how does having this amount of information, both actual augmented reality and then abstract information combined, how does that change decision making?
Yeah, Tyler, you're describing the modern battle space for us. From the fighter pilot contextual environment, flying against a jet is something you can see, but the modern battle space is fought over hundreds and thousands of miles with waveforms and enemy radars and IR. It's like sensors, a lot of sensors. And so when you look at right now, I came from an air operations center, which we were, the human is definitely in the loop, and we spend a lot of human capital focusing on just keeping our situational awareness high through multiple mediums, classification levels, and systems. So when I was doing dynamic targeting, I would have literally 4 screens with different information and somebody with a whiteboard marking down complex information, and half of it is actual real things, and the other is where am I getting the information from, the ones and zeros that you refer to. So when I look at virtual reality, I want, as the end user, to be able to go into an environment where I can take complex data that we're already stressed in the 2D environment with, and now allow us, because we're spatial beings, to get in that immersive environment and now starting to see the complex data. And then as we tie in AI with the previous discussions today, I want to go from in the loop to on the loop so that humans do what we do best, is we make risk calculations, whether we're going to put more resources to a problem, the ebb and flow of actual combat in a modern battle space. So, from our standpoint, in the MDO realm, it has huge room for growth. And then when we talk about the AR and pilot training, and again, it goes back to that learning. How can I spend my resources, which are constrained, and make a better product? And I think that's what this panel is showcasing, that the US military and the DoD at large, the smart partnerships with industry, with your companies, is absolutely required, because you can outpace us, and your pace of innovation allows us to have that interactive conversation where I can go, wow, this is really awesome, but what about this? And the next thing I know, you turn around and say, well, try this out. we don't work at that speed, but we need to get there. It's absolutely imperative that we get faster, and it's not going to be without partnerships that we've got here.
Right, thank you. And you say to get faster, and I think one of the things that comes to my mind is augmented and virtual reality are delivery mechanisms of communication. You know, they are technologies, but they are also mediums of communication, right? And so as a medium of communication, it gives you the ability to actually consume information faster and to be able to deploy that information faster as well. I just recently had on the VR AR Association podcast, I had the head of education at Microsoft, and he was telling me about a white paper that they've now publicly released, but I'm going to paraphrase the study, but essentially what they did is they put university students in lecture-based learning and then virtualized learning, and they arrived at a minimum standard for comprehension. And this was done across multiple universities across the country, and they arrived, at the end of the study, at the conclusion that the virtualized learning subset arrived at the minimum standard of comprehension 60% faster and with an entire letter grade increase over lecture-based learning. And the reason for this is because we're spatial beings. We want to be involved in the environment in which we're learning. If we're there, we have body ownership. We have a sense of our own self inside the space. And because we have that, we're able to take in information both through audio and visual, which is normal to a television screen or a simulator, but now you're also taking it in kinetically, and your muscles are actually remembering the information. So how, Lieutenant Colonel, how does this capability to actually learn faster, learn information faster, how does this change then the operational environment?
So, it's twofold, right? Complex systems, you change one aspect of the system, and then you see the effects downrange. Kind of what Daniel was talking about, the pilot shortage. When we talk about the levels of learning and how we learn as human beings, we're very focused in Air Education and Training Command on harnessing that, because if you can maximize your resources, you maximize the human performance, you can do things potentially faster. You can get a different product, when we call a product a pilot, that is ready for the multi-domain operations that they're going to face as whatever weapon system they go to. And so we have to also, we can't just throw technology at it, right? We have to make sure that we have the science, the data scientists looking behind this, and also the ability to iterate so that we can find out, when you talk about the peak performance, humans perform better under a certain amount of stress, but then there's a rapid fall off when you go over. And Danny and I were kind of laughing, talking about the helmet fire. I mean, that's when someone just locks up in its sensor overload. And so if you can go right to that, that's where instructor pilots over years of seeing students can push, but it's a very kind of subjective thing. If we can get to that objective ability to push that and then put it in a virtual reality where you can do iteration over iteration, we're going to get way faster.
Right. And Dan, did you have something to add?
Yeah, I think it comes down to how efficient are we with the resources that we have, right? We're always operating under capital rationing. We have finite resources. So the stuff that the guys are doing at PTN is some remarkable results in terms of getting guys and girls through onto the front line. Well, if you can take AR and the likes of what we're doing at Red 6 with the augmented reality dynamic environments, putting virtual airplanes into the real world that pilots can see against, well, how efficient can you be within each individual sortie? How many repetitions can you get rather than against a real asset? And so it leverages the technology to really increase efficiency with not just within a training syllabus, but within each individual training sortie as well. And it builds exactly on what you guys are doing at PTN.
So in terms of being able to get to insights faster, which is kind of the theme of the MDO challenge. So with one of the units we're working in the Air Force, they're trying to understand the data that pertains to aircraft maintenance, which is actually very complex data. And it currently takes them like about a week to come up with their report, which gives a snapshot of what's going on in terms of equipment maintenance. Now, with our technology, using a Python API, which is linked to our VR environment, we're able to clean, automate, process the data, and then visualize it in a way that they can really consume it in a matter of actually a few minutes. So you go from it taking a week to process it and not really being able to consume it because what you're getting is a 2D static report. You're actually now able to process the data in a couple of minutes and it's a much richer way of actually interacting with the data.
Definitely agree. And we have like 20 seconds left. Go ahead.
20 seconds left. Yeah, that's actually very interesting. We've found a lot of the same sort of thing where we're taking months and week long processes and condensing them down to minutes, which is very, very exciting about immersive technology. But I wanted to last statement, think about the way that since the day we were born as humans, we live in a three-dimensional and multi-dimensional world. Our brains, from a neurological level, are set up specifically to ingest and process data that is spatial. So when we are actually looking at a flat screen, we are demanding that we translate that flat screen from a multidimensional thing to a flat screen and then into our multidimensional brains. So using immersive technology really increases the bandwidth and removes that roadblock between the multidimensional data that exists in this world in a very abstract sense, and the way that your brain processes that multidimensional data. So it really is a bandwidth issue, and AR and VR solve this very, very well for data. So it is a brave new world, and I'm so excited to be a part of it.
Yes, and this was in 30 minutes we have accomplished this. Yes. I'm sure all of us could talk about this for much longer. Please feel free to reach out to the panelists, most of whom are demonstrating over here in the showcase. And there's lots and lots more to talk about. So thank you very much, Michael, Lieutenant Colonel, Dan, Susie, thank you very much for the time. Thank you, guys.
Thank you so much.